All right, here we're going to be talking about evaluating functions. So a function is really just an equation or a graph or a table, and evaluating that function basically just means matching up an x and a y value. So we just want to match up these two values that represent points in a table, points on a graph, or points in an equation, which means we might have to put a x number in, a replacement number in for the x variable, and follow order of operations, but essentially it's still just finding that x and y combination. There's one part of this function notation, this thing that we're going to talk about here, that might make it a little bit more confusing, but it's still just matching up an x and a y coordinate. So that function notation, it's describing a function in terms of the input variable, the symbol f of x, f, and then parentheses, an x inside the parentheses, and then close parentheses. That's going to represent the y variable. It replaces the y. It means the exact same thing. It's not saying f times x, it's saying a function of x. That's really how you'd read that, or you can read it as f of x. F of x is just a function of x. It's describing a function in terms of the input variable. The reason this is valuable is we can talk about more than one function at the same time. If we limit this to just writing it as y, we can't talk about a second function on the same graph. Now we're allowed to talk about as many functions as we want just by changing that front letter. We could say g of x, h of x, k of x. Those are all different functions, and we can talk about those on the same graph. When I talk about evaluating a function, I'm saying I'm replacing the input variable, the x, with a given number to find the value of the function, or to find basically the output. And when I write that, I could say it this way. I could say f of x equals 2x. So again, that's really just a replacement for y. You could also see that as y equals 2x when x equals 2. Another way to see that is the exact same information. F of 2 equals 2x. This is replacing the x. It's basically just telling us plug 2 in for x, like I'm going to show here. So still f of 2 equals, now I just plugged in the 2 for x. That's all that's really telling you to do. And you can see it here. In the parentheses, there was an x, now it's a 2. It's basically just saying, in the other side, do the exact same thing. Replace this x with a 2. So f of 2 in this function would equal 4. It would just be 2 times 2, that gave me that 4. So f of 2 equals 4. Or, you could say this a different way. As coordinates, you could say we have the point 2, 4. Remember, this is really just representing y. The whole thing, the f of 2, is saying y equals whatever this is. So the y coordinate is 4. The x coordinate, the number we plugged in, was 2. And that's how we represent coordinates. We write them in two different ways here. X comma y, or x comma f of x. Those are representing the exact same thing. These two things are interchangeable. And again, it's not saying f times x, it's saying a function of x. It's just describing the output of that function for x. So that's our x, that's our y, or f of x, and it really just represents coordinates on a graph. That's 2, 4. Okay, so now when we're evaluating using an equation, it's basically what I just showed you there. We're given an x value, or you could be given the y value. Either way, you're trying to figure out the matching x or y value. So on these first four, we're given the x value. So this one's written like you've seen it, y equals 2x minus 3 when x is negative 4. We're just going to plug negative 4 in for that x. That's all I did there. I just substituted negative 4 in. Anytime you substitute a number in, make sure you put it in parentheses. So it's 2 times negative 4, that's negative 8. Minus 3 would give us that y is negative 11. Another way to say that is that f of negative 4, when we plug in negative 4, we got that equal to negative 11. The output was negative 11 when we had an input of negative 4. And yet another way to say that, as the instructions say, we're going to write this as an ordered pair. That's negative 4, comma, negative 11. Same kind of thing on this next one. F of x is negative 4 minus 9x. When x is negative 4, the first step is just substitute the number in parentheses. Now I'm going to follow order of operations. Make sure you don't subtract there first. We're going to multiply. I'm going to do a negative 9 times a negative 4. That's going to give me a positive 36, so I'm going to write that as a plus 36. So negative 4 plus 36 is a positive 32. Another way to say that is that y is positive 32. So that would give us the ordered pair negative 4, comma 32. Remember that this is the x value. The number that we get from this input, is the output, or the y value. Next one's written like the first one. We have x is negative 1, and y is that expression. So I'm substituting in negative 1 for x in parentheses. Just putting that negative 1 in there. I'm going to multiply negative 2 times negative 1. That's a positive 2, so I write that as a plus 2. And then negative 5 plus 2 is negative 3. And nothing about the bottom changed. You could write that as decimal if you really like to. You could write negative 1.5 if you want, but I'm just going to leave that as a fraction. So y is negative 3 over 2. We could also say that f of negative 1 is negative 3 over 2. And yet another way to say that is as an ordered pair. Negative 1, comma, negative 1.5, or that fraction. Alright, now we get down to this notation where we don't even see this extra part. It's not even saying x is negative 4. You just have to know that that is what that's implying. It's saying that x is negative 2. It's saying take negative 2 and put it in for every spot that you see an x there. So I'm going to take that and replace it with a negative 2. So negative 2 squared, again, put it in parentheses. That includes when you type it into the calculator. Negative 2, put the parentheses around just the negative 2, and put the squared on the outside of that. Negative 2 squared minus 3. Negative 2 squared is 4. Minus 3 would give us 1. So our y value is 1. And that is that ordered pair. Our x value is negative 2. Our y value was positive 1. And just to show you another connection, that's also just a point on a graph. It's negative 2, comma 1. It's just talking about that point in this function. This function has an infinite number of points. This is just one of them. Alright, we go back to this notation where they're telling us what x is. X equals 2. But I just changed the letter in front. It doesn't change really anything at all. This is just saying g of x. It's just a different function that they're describing. It's the exact same thing, though. It's still just saying x is our input. And here they're telling us directly what our input is. It's 2. So I'm going to start by just plugging 2 in for that x. Follow order of operations, so I'm doing my exponent first. That gives me 4. It's 2 squared. And then I'm going to do the multiplication. 2 times 4 is 8. And 8 minus 10 is a negative 2. So g of 2 equals negative 2. And that is the point, 2 comma negative 2. That's my y value in the coordinate plane. And that's what that graph would look like, 2, negative 2. Here I see that I have an h. Again, it really doesn't change anything. It's just saying it's a function of h in terms of x. Again, I'm just taking that number and plugging it in anywhere I see an x. That's my first step. I'm just substituting in negative 1 in place of that x, negative 1 in place of that x, negative 1 in place of that x. I don't change any of the signs yet. Don't do anything until you actually substitute it in. And again, I want to follow order of operations, so I'm going to do my exponents first. I'm going to do both of these at the same time. I know they're not really going to affect each other. So I'm just going to do my exponents. Negative 1 to the third power. It's like negative 1 times negative 1 times negative 1. That gives me back to a negative 1. Negative 1 squared. Again, the parentheses go around the number. The squared goes on the outside of that when you type that into the calculator. That gives me a positive 1. And now I'm going to do both of my multiplications at the same time. It looks like I only have one multiplication here, -3 times -1, but I actually see this as multiplication too. When I see minus a negative, I kind of see the imaginary -1 on the outside of this, so I see -1 times -1. That would give me a +1 or a +1 there, and -3 times -1 here gives me a +3. And now I just add straight across. 3 plus 1 plus 1 is 5, minus 10 is -5. So my y value is -5. My x value is -1. My y value is -5, and that is that ordered pair. Here we go back to being given that x is -3. Again, they could say that a different way. They could just say f of -3, like that. And they don't actually even have to give us this part of the sentence. They could just say f of -3, find the y value, or find f of -3. Really, that's what that's saying. Just find the value when you plug in -3. So that's my first step. I'm just substituting in -3 there and -3 there. So I want to make sure I follow order of operations. I'm going to go back to what I said on this one. This I saw as a -1 times -1. I'm seeing this the exact same way. -1 times an expression that's squared. This thing is raised to an exponent. I have to do my exponents before I deal with this -1. That's multiplication. Or you could even see it as subtraction, but either way, it comes after an exponent. So I'm just going to square the -3. That's a +9. But the negative sign comes down with it. So it stays really, that negative sign doesn't change. It's going to stay as a -9. Now I do my multiplication in the middle. That I see as a -9 times a -3. That's a +27 or a +27. And then I go left to right. I have addition and subtraction, so I just go left to right. -9 plus 27 is 18, minus 1 is 17. So my f of -3, or my y value, is 17. And that gives me the coordinates, -3, 17. Alright, we really got to look at this one carefully. F of x is this expression, and then it says f of x equals -1. This is not saying that x is -1. This is actually saying our output of this thing is -1. So we're solving for the other thing now. We're basically replacing this whole f of x. It's saying f of x equals that. So I'm going to replace the f of x with -1. That is going in place of this f of x because it says those two things are equal. So I'm just substituting that in place of this whole thing. I'm not plugging it in place of x. I'm putting it really in place of the y, and now I'm going to solve this equation for x. So I'm no longer following PEMDAS. I'm not following order of operations at all. I'm trying to solve for this x. I'm trying to get the x by itself now. So I got to get rid of this -20 first. I'm going to cancel that out by adding 20 to both sides. That would give me 19 on the left side, and that negative sign or minus sign is stuck on that x, so it's still attached there, but the -20 went away. Those canceled out. We got 19 equals -x. Still have to get rid of that negative sign. I got to get x completely by itself, so I'm going to divide by -1 on both sides. There's really an imaginary -1 being multiplied times that x, so I'm going to divide by -1, divide by -1, and x is -19. It's completely different from what we just did on the previous 7 questions. We solved for the x variable here. We didn't solve for y. They told us y right in the beginning. Y was -1. And that's how I'm going to write this. X is -19. Y is -1. That's the coordinates that they're talking about there. Alright, when we're using graphs and tables to evaluate, we're really just matching up points. As long as we understand the notation, it's really just looking for an x and a y coordinate. So on that first one, it says, what is f of 2? It's talking about the x value. That 2 is the x value. It's saying, find the y value when x is 2. So all I'm going to do is look at my x-axis, find 2, and then look up at my line. I'm going to just scroll up to my line, and I see that my y value right there is 3. Another way to just phrase that, it's saying 2 comma what? What is the y value when we have an x coordinate of 2, and that is 3. So f of 2 equals 3. You could also write it as coordinates if you wanted to. If you wanted to write an ordered pair, that's fine. 2 comma 3 would also work there. This is saying what is f of 0. So x is 0. What is the y value? X is 0. What's the y value? X is 0. That means I don't move along the x-axis at all. I just stay put, and I just go up to wherever my line is, and I see that it's hitting right there. That's the y-intercept. We'll talk about that later. But my y-intercept is 0, comma 2. Or another way to phrase that is that my y value, my f of 0, my y value when x is 0 is 2. Right, now it says what is x when f of x is 1. It's just flipping that around. It's saying what's the x value when y is 1. So I'm going to go to a y value of 1 and just scroll over to my line, figure out where my line is at that time. And it's right there. So my x value there is -2. So x equals -2. Again, you can write that as an ordered pair if you want. -2 comma 1 describes the exact same information as what this is asking. What is x when f of x is -1? Again, I'm given the y value here. That y value of -1 is here. And then I just think about where my line's hitting. There's no actual dot there, but it is hitting directly at -6. So you could fill in a -6 there, or you can just write that x equals -6. Same kind of thing on this one. We just have a little bit more complicated of a graph. They're saying the x value is 7. What's the y value? The x is 7. What is f of 7? What is the y value? So I go over to where x is 7, look down at my circle, and I see that my y value right there is -5. What is f of -1? I go over to an x of -1, and I see that actually it's still at -5 at that point. When x is -1, my y value is -5. So f of -1 is also -5. Let's say they had asked for f of 3. F of 3. There's actually 2 answers to that, and that's perfectly okay. It's not a function. That's what that really means when you have an x value that has 2 outputs. It's not a function, but you're allowed to have 2 answers. So we could have just said that f of 3 equals -1 and it equals -9. It hits both of those y values. On the 3 and 4, they're saying f of x equals a number, so that's giving us a y value. They're saying find the x value. What's the x value when the y is -1? Well, that's that point 3, -1 that we were just talking about. X equals 3 there. And when f of x equals -9, down to -9, what's the x value? There we see that it's actually still at 3. Again, you can write that as an ordered pair, or you could just say x equals 3. Alright, a table is really giving the exact same information as a graph. It's just writing out the ordered pairs. It's still really just matching, though. As long as you understand what that notation is talking about, that the x is inside the parentheses here, and that f of 0, when it's asking for f of 0, it's really asking for the y value. So it's asking that same kind of question as what we were talking about up here. F of 0, it's saying the x value is 0. What's the y value? You can see it really clearly in the table. When x is 0, when the input is 0, the output is 7. When the input is 2, the output is 1. And you see that here, 2, comma 1. What is f of 2? What is the output when your input is 2? What is f of -1? What's the output when your input is -1? That's just 10. F of -1 is 10. These next 3 are asked in the exact same fashion, just matching it up, except now they're telling us that the f of x equals some number. What is x? When f of x equals 4. So when the y value is 4, or you could say it like that, when the y value is 4, what's the x value? It's just saying what's the input to get us that. It would have to be 1. So x is 1. This one's a little bit messy, but it's saying the same thing. F of x is 7. What's the x value? So y equals 7. The x value is 0. It's the exact opposite question as number 1. And what is f of x? Sorry, what is x when f of x is 1? So the y value here is 1. What is the x value? That's just 2. So when you're evaluating a function, either when you're given the x or the y, you're really just finding the corresponding part of that ordered pair. Sometimes it involves a little bit more work if you're given the equation. Sometimes it's really just matching up on the table, and sometimes you actually have to look at the graph.